Scientists found a new black hole in our galactic neighborhood, and NASA confirmed that that piece of debris that hit a house, it was from the ISS. These stories and more in this week's edition of Space News from Ad Astra. Welcome, I'm Swapna Krishna. If you're curious about NASA's wild announcement this week about returning samples from the Red Planet, a mission called Mars Sample Return, I had so much to say about that I filmed an entirely separate video. So check that out if you're so inclined. It's certainly a strange story and there's a lot to dive into there. But in other weird news, remember that space junk story I talked about a couple of weeks ago, where part of a battery pallet jettisoned from the ISS may have hit a Florida home? Well, NASA confirmed this week that that debris was from the ISS. It was from support equipment that was used to secure the battery to the pallet, not the battery itself, as some of us thought. NASA did release the first part of its new space sustainability strategy last week, which has nothing to do with this particular situation, but it's also a good acknowledgement that space junk is a huge problem. This strategy basically lays out the goals in order to develop a framework for confronting this increasingly important issue. They also put out a cost-benefit analysis in March about remediation of debris on orbit. That is, reducing or removing space junk that is cluttering up low Earth orbit. The conclusions it comes to is that it is actually financially worth cleaning up small debris in orbit. It's really good that NASA is paying attention to this issue, but the report definitely has its share of problems. As Dr. Sam Lawler, who is an expert on satellite pollution and space junk, told me, and I quote, "This is a good step in the right direction, but it doesn't go nearly far enough." She points out that the report's satellite collision model, which looks at the potential of satellites to collide with debris, only uses US satellites. Additionally, the information is at times out of date and at other times wrong. The numbers being used generally are from a couple of years ago, and they only have SpaceX's Starlink at 1,815 satellites. She points out that SpaceX currently has 5,809 Starlink satellites in orbit, and they have permission to launch and operate 42,000. While this NASA report models collisions of debris with satellites, they don't address satellites colliding with other satellites, which is becoming a bigger and bigger problem. Additionally, Dr. Lawler points out that the report does not talk about what happens after these collisions, specifically the creation of additional debris. Remember the Russian asset test in 2021? Russia conducted an anti-satellite missile test against a satellite in space. This test created more than 1,500 large pieces of trackable debris and possibly hundreds of thousands of smaller pieces. The debris from this test even threatened the ISS, which had to undertake an avoidance maneuver because of a possible collision. Secondary debris from a collision is a huge problem that this report does not really address. The bottom line? It is a good start, but it's not a forward-looking analysis, and there are other considerations when it comes to space debris and junk other than just the financial cost-benefit analysis. But let's move on to some cool science news. Let's talk about a black hole. Scientists using the ESA's Gaia spacecraft data found a new stellar mass black hole less than 2,000 light-years away. This is quite the feat because it's a dormant black hole, and these are exceptionally hard to find. We can't generally directly observe black holes, so when one isn't actively consuming matter, they're just dark and silent in space. Scientists generally divide black holes into a few categories, but we're going to focus on one specifically. We all know about supermassive black holes, like the one at the center of our galaxy. These are the ones we talk about the most. They have masses in the hundreds of thousands to billions of times that of our sun. But here, we're talking about stellar mass black holes. When a star the size of our sun collapses, it becomes a white dwarf. When a star 8 times or more the mass of our sun collapses, it goes supernova. If it's between 8 and about 19 times the mass of our sun, what's left becomes a very dense neutron star. If it's 20 or more times the mass of our sun, what's left becomes a stellar mass-sized black hole. These black holes can grow by consuming matter, colliding with other stars, and colliding with other black holes. They are generally a few times the mass of our sun to a few hundred times the mass of our sun. The thing is, they're hard to find because unless they're interacting with something else, they're just quiet and they blend in with space. Black holes kind of have a bad reputation. People think of them as all-consuming monsters, but just talking as an example, I'm not saying this could actually happen, but if a black hole that was the mass of our sun replaced our sun, I mean, sure, we would die because we didn't have the light of our sun anymore, but the orientation of our solar system wouldn't change. All the planets would stay exactly where they were. A black hole affects the matter around it based on its mass, just like a star or anything else. If matter is outside that area, then it's not going to start sucking it in all of a sudden. We have only detected about 50 stellar mass black holes in our galaxy, but scientists think there could be as many as 100 million. And now scientists using the ESA's Gaia telescope, which is working on making a 3D map of the Milky Way, have found a stellar mass black hole that is 33 times the mass of our sun. In the constellation Aquila, scientists noticed a wobble in a star's path. They analyzed the wobble to try and figure out what was going on, and the readings matched a stellar mass black hole. This is the third stellar mass black hole we have found with Gaia, and it gives us the clearest direct evidence that these black holes are not theoretical and do in fact exist. In other cool science news, NASA has confirmed the Dragonfly mission, which is a robotic mission to study Saturn's moon Titan. The mission was on hold pending budget, but now the confirmation has come through with the cost of $3.35 billion and a launch date of July 2028. This is a cool mission for a bunch of reasons. We think Titan has a water-ice crust with a salty ocean underneath. It has rivers, lakes, and seas of liquid ethane and methane, and even sand dunes. It's a very cool and interesting world, and it deserves a closer look. Now it's going to get one. Dragonfly is cool as well. It is a dual quadcopter that will travel across the planet's surface in hops, traveling much further than a rover could from its landing site to explore the planet. The mission will last 2 years. I also have a few pieces of launch news. First, Boeing Starliner has been rolled out to the launch pad. This will be the first crewed test for Starliner, taking 2 astronauts to the ISS for a week. It's currently scheduled for no earlier than May 6th. Additionally, Rocket Lab, the small rocket launch company with a mostly 3D printed rocket, will launch a demonstration of NASA's solar sail technology. This launch is currently scheduled for Wednesday, April 24th in New Zealand, which would be Tuesday, April 23rd in the US. The rocket will deploy a CubeSat, which is a small satellite about the size of a microwave, in Earth orbit. After a 2-month period of checking out its systems, the satellite will deploy its solar sail to test propulsion based on just the pressure of sunlight acting on the sail in space. And that is about all the news I have for you this week. Thank you for watching. I'm Swapna Krishna, and this is Ad Astra.